Hi folks and welcome. Today we will build on our first two tutorials and add in planet player gravity. Flying around in empty space is no fun, so let's add a planet and give it some gravity. In the Unity editor, add a new game object. We'll rename this one Planet. We will give it a rigid body and a collider. At this point we'll turn off use gravity before we hit play. We will also add a sprite renderer, and I'll just drag in a generic planet sprite that I have. I think I'll also need to resize this. We will then add a script to capture the gravitational interaction between the planet and the player. We will double click on the gravity script to begin to edit it. In the gravity script, we will reference the player rigid body. We will also need to reference the player transform. We'll also define a float for the gravitational strength of this planet. And for reference, we will also show or display the distance between the player and the planet object. We'll also need a vector that captures the gravitational force, or the vector along which to apply the gravity or the force within the physics engine. In the start function, we need to reference the player rigid body as opposed to the rigid body of the planet. Directly now we will change the update function to fixed update, and we will capture a variable that will illustrate to us the distance from the planet to the player, and we'll use a built-in vector2 method for distance, passing in the player transform position and the transform position of the object, which in this case is the planet. Next, we want to calculate every frame the gravitational force, and to do this we need first to establish a direction, and that is the difference between the transform position of the planet and the transform position of the player. That is a direction vector, so we will normalize this so that the direction of the vector and the length of the vector is 1. Next we will multiply by the gravity strength. That's just a float value that we can alternate to make the gravity stronger or weaker. Then we'll divide it by the distance to the player squared, and that is the standard equation for gravity, the r² dependence. Next we have to apply the gravitational force to the player body, rigid body, and we'll do this again through the add force method here. We will save the script now and go back into the editor in Unity. We will need to drag the spaceship object into the gravity script and also set a value for the gravitational strength of the planet. Now typically in real life this would be the mass of the object. In Unity we'd simply just capture that with the value. Testing this out. That is a bit slow. Let's increase the gravitational strength. And retry. A bit better. Let's reposition the planet to the center of the screen and increase the gravity and retry. We can see the gravity is working, but also there's some collision. Let's check that. The collision appears to be with the capsule collider on the spaceship. So we will change the radius and also the height of the capsule collider. So let's save the game. Let's set the game to play on focus so it doesn't go full screen, and let's test it out. You'll notice the distance to the player is updating as the player rotates around the planet. We may need to update the field of view on the main camera, and to do that you click on the main camera object and set the size. So we can see the planet is still in the center and the spaceship is orbiting around it. The player can move and boost and turn the spaceship. And now we are in a more circular orbit. So there you have it. Solar Jetman physics and thrust vectoring. Now we can kind of push it a bit. You can copy the planet object and paste it in the editor, and it should work directly. So you have the spaceship orbiting around both of the planets here. We can add another planet and we can just see what the interactions are like as we add more planets. As we crash into the planets, there are some interesting physics at play here. It is the 1/r² dependence that's giving it this unique behavior. The closer it is to the planet, the stronger the force is. You can see we have a rotation around all three planets there. And then finally, we can add negative gravity. So the green planets here have negative gravity, and the red planet has a really massive value for the gravitational strength. So we do a few orbits around the red planet, and then I try to circularize the orbit, and something interesting happens. So we get caught in the middle, and you can see that the green planets are almost pushing the spaceship around the orbit of the central planet. We go around a few times before the red planet ejects us. So there you have it, it's a Unity introduction where we covered a lot of the basics, and we have achieved the Solar Jetman physics and mechanics, level gravity and planet gravity. So that wraps it up for this small tutorial series. If there's anything else you'd like to cover in Solar Jetman, let me know down in the comments. See you next time.